Hey mathematicians, in example number 4, you will hopefully notice that this equation is in point-slope form. So the best thing to do is to start by figuring out what is the point that is embedded inside of those parentheses. And what makes point-slope form a little confusing is that when you're graphing a coordinate, the x comes first and the y comes second, but in the equation, the x is here at the end and the y is in the front. So allow me to illustrate. So the x coordinate is going to be this one right here because it's x minus x1. And then because it's a positive 3, so first of all, we know it's a 3. And then because it's a positive 3 inside of that equation, and it was x minus x1, that means that it must have originally been a negative 3 before you put it into the equation. So the x coordinate is a negative 3. And then to get the y coordinate is second in the coordinate, but it's first in the equation. And because it's a negative 4 inside of the equation, that means that it must be a positive 4. So we've got that coordinate, negative 3, positive 4. So that will be the first coordinate that we graph on the graph, negative 3, positive 4. And then after that, we're going to use the slope the same way that we've been using the slope in every other format of the equation. So the 2 is your rise, the 3 is your run. So because it's a positive, I'm going to go up 2, and I'm going to go to the right 3, because if I go up 2 and then to the right 3, since those are both in a positive direction, that makes the slope positive. Now, I don't have room to go up and over to the right again, and I need 3 coordinates, and I have enough room on this paper to do so. So I'm going to go back to that coordinate, and I'm going to go down 2 and to the left 3. Because if you go down, that's negative. The left is also negative, and those two negatives will make that slope a positive. And then I'm just going to add my line. Which this one's going to be a little shorter here. And add my arrows.